Hello guys, how are you today? Finally, the time has come and today I'm gonna show you how to build a Kira Kira effect from scratch. Let's open our Spark. And for those who doesn't know what Kira Kira is this effect with those sparkles you can see here in this image. It's very popular, many people are putting this Kira everywhere. And for what I know, Kira means it's a Japanese name for something that is shiny or bright or sparkle. I'm not sure, but I think that's the meaning. So let's begin. Let's open our patch editor, Control P. Let's bring first our camera texture. Let's extract them. The camera texture and the device resolution. The device you can just drag it here. And the camera texture too. Okay, let's start with those two patches. So the first step is to create an outline image, like an image with only the edges, because I don't know if you noticed, but the sparkles in the Kira effect, it shines at the border of the object, so walls, windows, and the border of our body too. So we have to start detecting our edges. So I already made a tutorial about how to detect edges. So if you're not sure how to do it, you can check in the link here, this tutorial about how to detect edges using the convolution patch. That's the patch you're gonna use right now. And also you're gonna need the knowledge of how to pixelate an image. I also have this tutorial here, you can click, and how to copy an image using the function patch. So these three tutorials that I made before, they are very useful to understand this tutorial here. So I recommend you to watch it in case you have questions about it. So let's come here in the AI library. Let's import the convolution patch. I think here in shaders you can find it. Here. This patch here, the convolution patch. Let's import it and close it here. Bring this patch here. And we're gonna connect our camera texture and the texture input. Let's converge to patch group. So before connecting to our texture input here, we're gonna turn our image black and white. And how can we do this? We can add a swizzle. Swizzle is a very useful patch. And to make it black and white, we only need to use one of the three colors, right? One of the red, blue, and green, so you can use only the red. And the alpha is gonna be 1. So I'm gonna insert it here. I'm gonna create a rectangle so you can check the result of what we're doing right now. So add the rectangle here. Create material. Set it to flat. And bring our texture input here. So right now we have only the black and white image. And what we have to do to create our outline, we need to put some values here. It's gonna be -1, -1, -1. As I told you before, I showed you why we have to do this in the past tutorial. You can check there. -1. And nothing changed yet because we need to add here our texture size. And the texture size is going to be the size of our screen. That's why we already dragged this here. Let's connect the screen size to this input. Okay. And now what we have to do is swizzle this output. Let's swizzle X, Y, Z, and the alpha. It's going to be 1. And connect. Okay, now you can see only the outline, right? The edge of our image. Let's see with other cameras. Look. If you want wider lines, wider outlines, you can divide the texture size, in our case the screen size. Let's apply division here. Let's divide by 2. See, when we divide, as we increase the second value here, our outlines get wider and wider. Look. I think 2 is okay. Leave as 2. Yeah, 2 is fine. And the next step is going to be to pixelate this image. Okay. And as I mentioned before, I also have a tutorial about how to pixelate an image. So let's do this now. To pixelate an image, we need the function patch. We need a multiply. We need one round. That's going to be responsible for round the color. And a divide patch. And those patches here, they need to be vector 2, because one value is for the x direction and the other one is for the y direction. And the number we're going to divide here, the second value, is going to be how many pixels you want in the screen. So if I want 8 pixels in the x-axis, I put 1/8 here. And the y value has to be proportional to our screen size, right? So we need to do a calculation to know when x is 8, how much y is going to be. So how can we do this? We're going to unpack our screen size so that we're going to have our x and y values. Okay, we have x and y, and we're going to divide one by the other. Let's divide y by x because y is always higher, a higher value, right? Our screen has always more height than width. So let's divide y by x. So now we have the proportion of our screen size. Let me organize this here. Let's comment to keep it organized. Gonna be screen proportion. And now, using a multiply patch, we can multiply the x value by our screen proportion here. So if I wanted to have 8 pixels in the x-axis, like I told you before, we can put 8 here, the number 8. So in the x-axis, we're gonna have 8 pixels. And in the y-axis, we're gonna have the result of this multiplication, right? So if I pack this value here, vector 2, because the first value is going to be x and the second value is going to be y. So if I want 8 pixels in the x direction, I'm going to have 14.2 pixels in the y direction. When I have the screen size, if I change the screen size, for example, let me try Android S9 here. Samsung Galaxy S9, we have different values, right? If I put 8 pixels in the x direction, I'm gonna have 16.4 in the y direction. So to organize this better, I can just add one value patch here, value, and this is gonna be the amount of pixels that the x direction gonna have. So I can put 8 here now, and connect here too. So now we have a vector with the number of pixels in the x direction and in the y direction. And now I can connect the output of the spec to the multiply here and the divide. So you're gonna have always the right values. And now to pixelate our image, we need to add this output to a composition patch, right? So what's gonna happen is that the output of this patch is gonna be the input of all these patches here, because in this composition we put one function inside another function. So okay, now let's connect all. And before we connect, I almost forgot, we have to set the function patch as vector2, because we're receiving one texture, right? It's a 2D texture, so it has to be a vector2 here. Otherwise, it wouldn't work. Let me also group these blocks here. Let's comment around. It's gonna be the number of rows and columns. Because this project is gonna be so big, it's better to keep it organized, okay? So now let's connect and see what's gonna happen. And that's what happens. So when I was trying to do this Kira tutorial, I faced this problem. I don't know why this happens. If someone watching this video can explain why this is happening, because the output of this whistle here, it's only the outlines, only its edges, right? Let me make it a little thicker so you can see better. It's only the outlines. So this texture is the input of the composition here. So the output should be this image, this pixelated image, right? Because when you put something, when you connect something, some texture in this F input here, for example, I'm gonna put the camera texture here. Insert the camera texture. And you receive the pixelated image of the camera, right? That's what happens. If I increase the number of rows and columns, and let me put 16. See? I received the pixelated image, but I don't know why. When I insert this patch, I receive the image like this. So I tried everything here to make this work, but I couldn't. So the solution that I found two solutions. The first one is to add one shader in the path here. add a shader render pass. So when we're using the shader render pass, we need a device. So let's add a device. Oops. You have to add here, right? The device, render pass here. So as expected, we have the output as we had before, same output. You can see here. But when we insert first the shader render pass, and then we connect to the composition patch, now we have the image pixelated. We have the pixelated image, as we were expecting before. See? That's the result that we need. That's the image, the outline image with only the edges pixelated. You can see the other images here. That's the result that we need. And as we decrease the number, the division number in this patch, our pixels are darker and darker, right? And when we increase, we have more pixels and they're brighter. So let's go back to 2. And now we have the output that we need. However, when we use shader render pass, we are not able to use retouching. When we add a face mesh, we can't use the shader type retouching. Usually, when we use a Kira effect, we also need to use a retouching in our faces. So, if you really need to use a retouching, the shader type retouch here, there's another solution that I found that is using this other patch, this other convolution patch called Convolve 3. I'm going to import to our project. So I'm going to leave it for the load. I found this patch on the internet. It does the same thing as the convolution patch we have in our AR library. It does exactly the same thing. But I don't know why. When we use this patch, we have the right result in the composition patch here. Oh, and when you use this patch, instead of using the texture size, we insert the strength here. We use the strength here, and we have to put the same numbers again. That's why it's not working yet. So guys, if someone watching this tutorial can explain me why the first convolution patch doesn't work properly in this situation, I would be very thankful. Okay. See, now it's working. With this patch it works. We have the result that we want. So I'm gonna keep using it because I like to use retouching in our filters, in my filters, because that's what most people like, right? To hide their pimples and their wrinkles. So I'm gonna delete the shader render pass, but if you want, you can use it, okay? So you know that this is possible too. And I'm gonna also delete this convolution patch, so we can use only this one. I'm gonna remove the device from here. And now we're back to where we stopped. Look, We have the image with the outlines, with the edges. Here we can control the thickness of our edges and the strength. See? So we won't need this division anymore. Now we can connect our composition to our material of our rectangle. And that's the result we need. Almost the result we need, because there are too many pixels here right now. So to control the number of pixels we have in our image, we're gonna use a step patch, step, and we're gonna set a threshold here in the edge. So every pixel that has more than 0.5 is gonna be completely white, and pixels that are less than 0.5, like the grayscale, the dark gray ones, they're gonna be all black, and the lighter ones gonna be all white. See? Now we have our pixels that we need, and we're gonna use these pixels, as we might be expecting right now, as mask for our sparkle. So wherever there is white pixels here, that's gonna be where our sparkle is gonna be, right? So now let me group those patches, comment around, right? Pixelate edges. Okay, our next step now is gonna be hide all the black part, here, and this white part, we need to blend it with the sparkles. So let's do this now. So now let's focus in our sparkle. I'm gonna import the sparkle here. You can use any sparkle that you need, that you want. I'm gonna leave this one for download too, if you need. So now what I'm gonna do is to make multiple images using the function patch as well. And as I mentioned before, I have a video showing how to do this. So if you think I'm going too fast right now, you can check this other video where I showed you how to make multiple images using the function patch. So let's bring another function. We can use the same function there, but to keep it more organized, I'm gonna use another one. Set it as vector2. And to make several images, we need to add a multiply, a module, and a composition as well. And the first input of our composition is going to be now our sparkle. Okay, let's set our multiply as vector2, because we need the x and y value, right? So we need it to be vector2. And here, and the second value is going to be how many copies we want in both axes, in both direction, x and y. So we're going to need the same value we already have here. It's going to be the number of copies in the x direction and the number of copies of our sparkle in the y direction. Let's see what we have right now. Look, that's the number of sparkles we have, because it's set as 16 in the x direction, right here in this value. So if I want 8 only, now you have 8 copies of our sparkle in both directions. And here we have our pixelated image. And what we need to do now is to blend our sparkle with these white pixels. So the sparkle is going to appear only where we have white pixels here. However, if you notice, let me show you with the camera texture what happens when you pixelate an image. I'm gonna skip this step right now, but when you pixelate an image, I'm gonna decrease the number of rows and columns so you can see it better. So we count here 4 pixels, right? Because we set number 4 here. So we should have 1, 2, 3, and 4. But there is like a shift. You notice that? So half of a pixel is in this side and the half is in the other side. Same thing in the y direction. We have 1, 2, 3, 4, 5, 6, 7, 8, and a little in this other side here. So we need to do this shift in our sparkles, because as you can see, our sparkles are all aligned. So we need to make it matches. We need to make them match our pixels. Oops, here. Our pixels. So let's do this now. We need to shift our sparkles. And put this back here. Oops, here. So now let's match our sparkles. To do this, you need to add one value before our multiply. So let's add one add patch, also a vector 2. I'm going to connect it to the multiply. Okay. And those values going to be the division. Let's add a divide. Vector 2, because it's x and y direction. It's going to be the division between 0.5, 0.5 in both directions, because our shift is going to be half of a pixel. So it's going to be 0.5 divided by the number of columns and rows also. So we connect this here. And the output of our divide we add here. See what happened? Pay attention. We're going to connect here. We have this shift. So now our sparkle matches exactly our pixels that we have put here. Now we only need to blend those two images. And how we're gonna do this? We're gonna multiply both outputs so everything that is black, its output here, multiplied by this other image is going to be equal 0. Because you know, when you think about colors, black is equal 0 and white is equals 1. So the output is going to be white only when you multiply 1 times 1. So when you multiply both images, this one and this one, this image is going to be like a mask of the other image. So you're going to see only where there is white parts here. So let's see the result. So that's the result we achieved until now. And what we need to do now to finish it is to hide all the black sparkles. So only the white one's gonna show up. Let's do this now. We can do this step in two different ways. We can unpack the RGB values here. And the alpha, right? So I need vector 4. And pack again vector 4 as well. And we pick one of our channels, R, G, or blue, as the alpha, because they're only gonna have values when they're not black, right? Otherwise they're gonna be equal 0. So the other values here, it's gonna be all 1. So that we have white sparkles. So when you connect, we have our result. However, it's not perfect, right? Our sparkles are not correct because we need only the transparency part. So to solve this problem, we can add a swizzle here. Sorry guys, because it's funny, those sparkles. So we can add a swizzle here after this composition. The composition of the sparkle. And we pick only the alpha value. And we connect here. Now, yeah, now it's perfect. Finally have our sparkles, our Kira Kira. And here, in the end, you can choose the color you want, like switching those values, because they are the RGB, right? So if you have 0 in the G and 0 in the B, we're gonna have red sparkles. If you have 0 in the red and 1 in the G, you're gonna have green sparkles. And also we can change the thickness of our borders, of our edges here in the strength of this convolve patch. So when our borders are thicker, we can detect more pixels, more white pixels. So you're gonna have more sparkles. And we can change the size of our sparkles when we increase the number of rows and columns in this value patch here. Let me put 8. See, I have many little sparkles, tiny sparkles. 16. So we have more and more. So you can play, you can decrease the thickness again, so you don't have too many sparkles. See? Let me try different cameras. Oh, and you can notice that they only detect, we only see the sparkles where there is borders, where there is edges. There's still a lot of sparkles. Let me decrease this. Okay, now it's better. You can control, you can put a slider and control this value here. Let me try on myself. See, now you can see any sparkle here. I think because my image, the image of my camera is a little blurry. So let me increase this strength. Yeah, now you can see the sparkles. Let me decrease the value. Oh, so now we have bigger sparkles. Here are sparkles. We can play with the blend mode, add, subtract, multiply. You have almost transparent sparkles, and replace doesn't work. And that's it, guys. Today's tutorial was very complex. We used the knowledge that we learned in the past 3 tutorials. That's why I made those 3 tutorials, because in this one, this final one, we would achieve the Kira effect. So we learned how to pixelate an image, how to create copies of an image, right? And how to detect edges. So in the next tutorial, I'm gonna add some more functionalities to the Kira. I'm gonna add a shift, so we can shift the sparkle, so we can add more than one sparkle, right? You can add one sparkle, a little shift compared to the other one. So you can add different shapes of sparkles. So guys, I hope you enjoyed. Please give a like, subscribe to my channel. This tutorial was a lot of work, so it was very hard to find the solution for this problem here, right? That convolution patch that didn't work, only with the shader render pass. I don't know why. If you know, please comment here why. And that's it. This tutorial is very long right now, so see you next time. Bye.